Hi there, it's Autumn. In the last video, we talked about what the numbers in our layer initialization means and how does that relate to the output shape we have down here and how to understand the math of these numbers. In this video, I want to talk about what the numbers in this param columns here means. What are these numbers and why do we have some zeros here? So parameters are the value that the machine learning model will have to tune through its epochs to maximize the accuracy or minimize the loss. To make it clearer, let's dive into how we get the number of parameters for the first convolutional layer. As explained in the previous video, we have 16 5 by 5 by 3 convolutional kernels. The machine learning model will have to determine the value for each of these pixels. And so there are in total 16 by 5 by 5 by 3 values that the model will have to determine for 16 of these kernels. And so this would total 1200. So what are the 16 here in the parameters comes from? Those are the bias terms. So for each kernel, we have one bias term, and so because we have 16 kernels, we'll have 16 bias terms, and if you plus these two, you get 1216 as the total number of parameters that we have in this layer. Similarly, for this layer, we have 32 of 3 by 3 by 16 convolutional kernel that will total 32 times 3 by 3 by 16 plus 1 for the bias term for each kernel, and so we will get 4640 total parameters. So why is the parameter of the max pooling layer 0? Well, it's because max pooling only slides the kernel across an image. So let's say this is our image. And max pooling will just slide its kernel. In this case, it's default to be 2 by 2. We'll slide it across the image like this, and for each place, it will get the max value of that area out. And so regardless of what values the image have, max pooling will just consider the maximum value in a 2 by 2 area and then get out that value and then put them in a new output. And so there's no parameters to tune here. Similarly, for the flattened layer here, it just flatten out the multidimensional arrays representing the image to be a 1D array of numbers, and so the operation is the same. There's nothing to tune there. For the dense layer, let's visualize it out. This is the output of our flattened layer. We have 8 total nodes, and so the dense layer will connect all of these to one output node. And for each of these connections, we'll have one weight, and at the end of all the connections, we'll have one bias. So in total, we have 123,008 weight terms and one bias terms, which give us this value here. And total parameters here is just the sum of all the parameters we have here. I hope that helps. Have fun learning.